This is Kishore from Department of Electronics and Communication Engineering from Marri Reddy Institute of Technology and Management. And today we are going to discuss about the main objectives of microprocessor and microcontroller, which is one of the subject in third year first semester, where the sub code is MLRS R22. And about this subject, what is the basics about the microprocessor and what is the basics about the microcontroller, and what are the differences between the processor and controllers, and what will be the first microprocessor. So all these things will be going to be learned in this particular session. So before proceeding that, why we need to study this, what is the major objectives of this particular course is to understanding architecture of a microprocessor, because it is very important to know the basic architecture, because from the starting onwards, whatever the evolutions are going to be takes place, that is done in terms of an architecture only. So it is to know that what is an architecture of basic processor as well as the controller. Then again we need to get some knowledge or how to programming those microprocessors or a microcontrollers has to be another objective of this. And not only that, and the various interfacing techniques need to be known, because if it is a microprocessor alone can't be function, because it has to be interfaced with some other devices also. So the techniques how the processor or a controller need to be interfaced with an other peripheral devices, which is also need to be known. And also we are going to be learn different techniques to interface, as well as the end of this course we are going to need to be learn about the advanced microprocessors and microcontrollers. So these are the few objectives of the course. And then when you go for an introduction of the course, what is a microprocessor? So generally microprocessor is nothing but a multi-purpose programmable device that accept the digital data, process it and instruction and send it to the memory. So basically what we understand, it is a multi-purpose which can able to done a multiple tasks simultaneously, that can able to programmed, and that has to be accept the digital inputs, and that input has to be processed and has to be stored in separate memory location as an input or an output devices. It is one of a definition of a microprocessor, and we can also define the processor as like that. A processor is a multi-purpose programmable clock-driven, register-based electronic device that reads the binary instructions from the storage devices called memory and accept the binary input and process the data according to the instruction and provides the result. Is another kind of a definition of a microprocessor. Then when you come for the first microprocessor is a Tomcat, is a first microprocessor which is designed by the defense. And the first commercially accepted microprocessor is Intel 4004, which is manufactured by the Intel in 1971, which is called as a 4-bit microprocessor, which is having a clock speed of 740 kilohertz of a clock, and which is a combined, it is manufactured in a single chip. So when you discuss about the first microprocessor and whatever the latest advanced microprocessor, what we are seeing now is an Intel Core Ultra 928 is an latest microprocessor which is having a Core 8 processors, which means that what we discussed or what we seen in 1971 is a single core, a processor which is having a single chip, which can able to perform up to a 740 kilohertz of the clock frequency. But then advancement happened, and now what we reached is in course of 8 such processors are embedded in a single chip, okay, and which is having a basic clock speed of 3.7 gigahertz of a clock speed to 3.2 gigahertz of different version. And also not only fixed with the particular clock speed, we can also boost that clock speed up to 7 gigahertz of frequency, which means that whatever the basic clock speed is there, whenever any processor is executing high-end applications, when the processor need to be execute much application, then in such cases the present processors can boost the clock frequency, what is the basic clock frequency, to the 5.7 gigahertz clock frequency, and which is having a cache memory L2, L3 memories can be used, and which is also integrated with multiple integrated designs, and which can able to embedded with the memory support and different PC slots, and which is having a TDP of 120 5 watts to the 250 watt. So thermally what it means that when our executing or when our processor is running a particular task, how much power is consuming. For that, TDP is one of the parameter where TDP tells that in the basic operation the present controller can use the power up to 128.5 watts of power consuming when it is going for high end applications, or when it is executing n number of tasks simultaneously, it can able to consume 250 watts of the power. And with next define of a microcontrollers. So again, when you come for a microcontroller is a single integrated chip which can be embedded not only with the processor but also along with some memory elements also. So if you see the definition of microcontroller is a small computer on a single chip that controls the electronic device by executing pre-programmed set of instructions. So at the end of the course, we can see the what maybe the differences will be the processor and controllers. So in the basic starting microcontroller is in 1976, which is called as an Intel 8048, is the first microcontroller which is an 8-bit consists of 8-bit microprocessor and the clock speed of 1 megahertz and the RAM of 1 KB onboard RAM and ROM of 64. So these are the few specifications of the first microcontroller, and now we'll see where we are reached in terms of a microcontrollers. Okay, the latest microcontroller we can say ARM Cortex-4 M85 is introduced in 2023. It is a latest processor which having a bit width which is nothing but 32-bit processor, which means that a bit processor or a bandwidth or a data width, it tells that how many bits it can able to execute at a time. Whereas if you go for a starting, it is an 8-bit microcontroller where 8 bits of a data can be processed at a time, where now we reached up to 32-bit microcontrollers are available, or 64-bit microprocessors are available, and where the latest clock speed of 1 gigahertz clock speed which we are using, and which is going to support a flash memory or supporting a large RAM support it is going. And when you talk about some of the features of latest microcontroller, which can be embedded within a digital signal processing with an ML capabilities, artificial intelligence capabilities, and supports a real-time operating systems also. These particular microcontrollers we can use in like IoT device, automations, robotic sensors, and high data processing units. This particular microcontroller can be used what presently we have. And when come for an introduction of the heart of the microprocessor is called as a central processing unit. Here it is showing that it is a central processing unit which consists of a registers, central unit, and arithmetic logic unit, where register is nothing but a few memory elements which are present to store a little bit of a data, along with the central unit which going to be consist of other parameters like buses, other things, and an arithmetic logic unit which is going to be performing all the arithmetic logic operations in the arithmetic logic unit. So all together we can call it as a central processing unit. So this central processing unit, we can say that it is in heart of a microprocessor. So if have a processor, a microprocessor itself can't perform any task, because in addition we require certain things called as a memory, because whatever the memory or registers which are present inside the processor or a central processing unit can't be enough to load or store enough data. For that purpose, in central processing unit along with the memory units also required. So here the diagram showing the central processing unit along with a memory. So if it is a memory itself, it is connected, it is again not sufficient. We required some bus interfacing techniques, how the data has to be communicated with the memory or vice versa. That can be defined by the term called as a bus interface unit. So if I'm saying that a processor, the central processing unit, and the memory is not sufficient to communicate to the external world or take the data, so we require some other parameters or some other things called as an input-output devices. So if a processor, microprocessor along with a memory and central processing unit and input and output, so called as a complete system. So if you say input devices, like we have a keyboards, mouse, joystick, and the various output devices we have. So output devices, we can say that monitor, printer, and it is completely, we can say that it is complete a computer system which consists of input output devices, memory elements, and central processing unit. So how does this processor can connect to the external world? This is the one question we need to be asked. We have all the parameters like CPU, we have a memory element having input output devices we have, but how, the question arises that how this is connected to the external world. So this processor can be connected to the external world called as a buses. Bus is nothing but a group of wires. Through the buses, this processor can communicate to the external world like an input output devices or an other devices. So we have a three kind of buses are available in microprocessor, like called as an address bus, data bus, and control bus. So address bus, by the name itself, it is specifying that if I want to transmit or send some data to the processor to the some input output devices, we require some an address. So this address information can be fetched into the processor by using an address bus. And similarly, when once the address found, then the data transmission can be taken place, and which can be done by a data bus, and the control bus which is provided the necessary control signals. So the control signal is nothing but what kind of operation is performing by the processor, whether it is going to be read operation or a write operation. When we talk about the read operation, whether the information is read a processor from an input output devices or a memory element. So such things can be given by this particular control bus unit. So now even though we have a buses, that is also not sufficient, we require an address decoder unit, because we need to decode which address I have fetched. So one unit we can say that address decoder, this is a unit which can decode the address and sends the necessary signals for read or write operations accordingly. So now we have known that type of a processors or a controllers, how it is going to be interacted. But which language processor can understood? Because as a human beings, whatever we speak like in English and other languages, the computer can't understand. So computer, these languages, what we can say that computer can understand only high level languages, where we can say that some of an example C, C++, Java, Python, these are called as an high level languages. If I write code on these particular languages, processor can't be understood. So we required some tools to convert these high level languages to the processor understood languages, where we can use as some compilers or interpreters which can able to convert whatever the high level language into the assembly level language. Where this is a question that the processor can understand assembly level language, we need to write the program in assembly level languages. Even though if you wrote the code in assembly level language, it cannot be understood by the processor, because processor can understand zeros and ones. So we require a further conversion takes in place, which means that assembly level language to the mission level languages, which is can be used as an assembler, which can convert the necessary assembly language into the mission level language like a zeros and ones, or we can call it as an opcodes. So the major characteristics of a microprocessor, if you take, it requires an external peripherals in memory, input output ports to the function, because microprocessor alone can't be work. As I said that it requires an additional peripherals or additional devices like input output devices or memory elements are primarily is using for a general purpose computers, laptops and servers. And the current version of a microcontroller, as earlier said, that microprocessor is a core i9 microprocessor, AMD Ryzen is using for personal computers, ARM Cortex is for small cell phones and tablets we are using, and RISC-V processor we are using a open source microprocessors. Similarly, when you come for a microcontroller, the key features called as it is a self-sufficient with built-in memory and peripherals, which means that as it is not required any additional memories, because the microcontrollers are going to be used for a particular task, a single task or a particular task. If I want to perform, the best choose is a microcontroller has to be chosen, and which is designed for a dedicated task, as I said, that dedicated task in embedded systems, and which is a low power consumption and low cost and effective things. And the present, as I said that we have a ESP32 with an Wi-Fi and Bluetooth IoT enabled, and STM32 microcontrollers, and Arduinos for users. Students want to do some projects based on microcontrollers, they can use the Arduino series, as well as the Raspberry Pi. These are the few microcontrollers where the students or a programmers can be done for a limited applications. So if I come for the differences of microprocessor and microcontrollers, when you say that about the future, if it is a core functionality, microprocessor can be used for general purpose processing, where the microcontroller can be done for the specific task applications. So when you come for an integration, the processor requires to be integrate with input output and some memory elements, but the microcontroller doesn't require any other things because it is included or it is embedded within some memory and IO devices. When you come for a cost point of view, microcontrollers are little bit less cost compared to the microprocessors. And when you come for a power consumption also, the processor consumes a higher power than the microcontrollers. And programming languages, we can use a direct embedded programming we can be used, whereas a general computers, Linux or Windows is a programming languages for the microprocessors. And as I said that there's a few examples also, the microprocessor is Intel i7, i9, AMD Ryzen is the examples of the microprocessor, and the controllers like Arduino, ESP32 and STM32 are the examples of microcontrollers. So this is the end of introduction of the microprocessor and microcontroller and little bit introduction. At the end of the course, the main outcomes of the students will be student can able to learn the is the knowledge on the microprocessor and microcontroller, what is a processor and what is a controller, and they can differentiate between the processor and controllers in respect of applications, and they can able to use in which application what type of things can be used, like a processor or controller. And they can use the understanding of an assembly level language and assembly level instructions, because it is not either a high level language or nor in a mission level language, because a mission level language human can't be understand, even it is very difficult to write a programming in mission level language. But by end of this course, students can learn how to write a program for the processors or a controllers in an assembly level language. Okay, and then they can use to analyze the practical applications and how to interface. Suppose if I want to be interface a keyboard to a microprocessor, such things can be learned in this entire course, how to interface a microprocessor to the keyboard, or some converters AD to ADC or DAC or a stepper motor, other peripherals, whatever the peripherals, how it can able to interface, can able to identify, and is can able to done very easily. And also they understand the processor latest architecture of ARM processors, and also they can use for real-time applications, which means that in this entire course the student can able to learn about the not only the microprocessor and microcontrollers, and the little bit advancement of ARM processor can also known. So end of this I will complete this, and next section we'll see about in details about microprocessor and microcontroller. Thank you.